Hello. When I woke up this morning, I wanted to learn something new. Is there more to learn? Well, I have never really understood how a bipolar transistor works. So I have tried to dig into that, called some friends, surfed on the internet, and now I think I have a simple explanation. Let me proceed. Let me try to make it simple. Here you see two materials. One is doped with atoms that has an excess electron, and the other one is doped with some atoms that lack one electron. The whole thing here is neutral, and this is also neutral. But when we put them together like this, the electrons from here will diffuse into here, and then we will have positive here and negative here, and we have created a barrier, a voltage barrier over here. If we apply voltage here in the other direction, you see that this voltage barrier is getting less. If we do it vice versa, you see that this voltage barrier is getting greater. So here you see the diode characteristic. If you are down here, that means we are here, and we see that there is still a current going, I2, and that is called the saturation current. And when we come up here, you see there is a large current going in the other direction. It's plus. So then you have this current. If you increase the potential difference between plus and minus here, you will have a great current going through this diode, which is shown here. Let's look at the bipolar transistors. They are used in analog amplifiers and in analog integrated circuits. It looks like this schematically. It has a junction here, a PN junction here. There's a kind of diode. And you see here, we have put a plus here and a minus here. And then we are creating an applied field here. And if it's larger than 0.7 volts roughly, it will lead electricity. There will be a current going. So, and then that means that electrons from the emitter here will fill this base area. This is doped a little different than this emitter area. So some of the holes are filled in order to get the current from B to E going, but most of the electrons is dragged over here till the collector, and then you will have a current going like this. We can dig in a little deeper, look in a little more detail. Here is a more realistic bipolar transistor. Here you see the base, the emitter, and the collector. The base have a plus and a minus, so that you have current going from base to emitter. And you see here you have the P is just 1 plus, and the N is 2 plus. That means this is a little more heavily doped than the P. That means that the electrons that go from here into here have problems finding holes, and all those electrons that have problem finding holes will be dragged in this direction to the collector. So there will be a small current from base to the emitter, but there will be a much larger, roughly 100 times larger current to the collector. And it's built like this. It's N++ here and N++ here. And then we have just N here in order to have smaller resistance, so that the current easily goes from the emitter to the collector. And also this buried layer here of N++ makes this a small nice channel for the electrons to wander in. And then we have some isolation parts here with P plus and P plus, because this is created on a substrate. So this is not the only transistor we have on the substrate. There is a lot of these transistors here, so we have to isolate them from each other. And here you can see a diagram that shows how it works. Okay, you have a small varying current on the base that creates a large varying current on the collector. So that means that you have an amplification. So this is how it works as an amplifier. And this is it.